Welcome back, ladies and gentlemen, to Earth Science. We are going to continue now discussing on chapter 3.3, igneous rock textures. We've covered already the three different main groups, rock cycle, and the intrusive or extrusive versions of an igneous rock. Now we're going to talk about the textures you can have with it. There are three types of igneous rock compositions. Composition means what it's made of. You've got basaltic, granitic, and andesitic. These three types of igneous rocks are dependent upon what type of magma they're made of. Basically, different ingredients have a different outcome. Let's talk about basaltic. Basaltic is very dense, heavy, and dark. Pretty plain and simple there. They take on these characteristics because they're rich in iron and magnesium, giving it that dense mineral. These type of rocks generally flow from volcanoes, like the shield volcanoes found in Hawaii. Shield meaning it's broad domed, like this, broad domed, not jagged, straight up mountains. Basaltic lavas tend to be relatively fluid and flow like thick honey. However, they can also flow as brittle, crumbly blocks of rock. It's not written here, we'll learn about it later, but fluid-like or thick honey-like flows would be pohoihoi. And the crumbly blocks, brittle crumbly blocks one would be considered aha, both Hawaiian names. We'll get that later. Here's some examples of some beautiful columnar basalts. When they cool, they constrict, crack, and form these pentagonal shaped columns. Beautiful. Look those up. It's really pretty. The next group is granitic. These ones are opposite of basalt. They're light in color, lower density. And less dense, obviously, than basalt rock. Granitic magma, it's thick and stiff, versus what we read earlier where it's easy to flow. In basaltic, it does not flow easily with granitic. This is because it has a high percentage of silicon and oxygen, which are the main ingredients to make silica and quartz. So granitic types of magma, because they don't flow easily, they build vertical type mountains rather than broad shaped mountains called shield volcanoes for basaltic. So in this case, this silica and oxygen rich magmas cause it to not run out but just keep building up, and they have this creates a seal or a cap on the lava for the gas from escaping, thus creating a bomb, basically making it very explosive, as the example of Mount St. Helens. Here's some granitic rock in Yosemite National Park as an example. A beautiful place. And andesitic, it's somewhere in between basalt and granite. Density, color, and explosive nature. Excuse me. This is an example of a andesitic intrusive dike that's going through a native rock. Notice how it's got that bluish hue, grayish hue color. So think of anything between basalt and granite. That's what you got. Think of salt and pepper. Okay? Your lights and your blacks mixed together. Okay. Igneous rocks are identified by knowing two main features. Texture and color. That's the two main features of igneous rocks and how you identify them. Below is a list of different types of igneous rock textures. Pegmatic, large crystals, very slow cooling. And it's an example of it. Make sure you write these down, these are very important. Phaneritic, between 1 and 10 millimeters. Pegmatic is the size of your pinky nail. Phaneritic is it's all visible crystals, phaneritic, up to that size. Still slow cooling, thick crystals, all visible. There's an example here. If you see a lot of pink mineral, which you see here as well, it's called orthoclase. That's a guarantee you're going to be in this region. Almost guaranteed, not always. Third one's porphyritic. When I say large, I should say large crystals with microcrystalline matrix. What I mean by that is, as an example here, you can't see that brown, but you do know it's there. You just can't see the grains, the minerals, but you can see these white minerals. These ones are large visible crystals. The brown matrix, you don't see them. It's just like kind of like a sugar cookie, right? You can feel the texture, but you can't really see the sugar grains. That's what this would be. Or like the night sky. You see the black night sky, that's a matrix. The stars are the large crystals. So it's slowly cooled to form these large crystals, but then it rapidly, slow and then rapidly cooled. So these were slow cooling, and then a change in the environment caused it to build, to cool quickly. Aphanitic. Oh, an example of this one would be chocolate chip cookie. Porphyritic, so pour in chocolate chip cookies or pour in the minerals, big ones. Aphanitic is like a sugar cookie. It has very few minerals, if at all. It's basically a sugar cookie. Really small grains, you can't see them, but you know they're there. So it had rapid cooling. And a lava is fluid. That's a good example of that. That would be like rhyolite, rhyolitic texture or color there. The next one is glassy. You can't see any crystals. It's very, very rapid cooling. Vesicular, no visible crystals by and large. It had super rapid cooling of gas-charged lava, so it's full of gases that eventually cooled over time. The bubbles are visible here because the gases used to be trapped in it. When it cooled, the gases escaped, leaving behind the hole. And then pyroclastic. Pyroclastic are fragments or pieces of the volcano when ejected out of the volcano, such as ash, tuff, fragments, pumice, volcanic bombs, etc. So it's all that stuff that got emitted out of the volcano coming back down, and it rewelded together because it was still extremely hot and solidified here. Okay, that's all the notes, ladies and gentlemen. Your job is to take this quiz right here. Take this quiz. There's about, 10 or so here. Answer, you'll get a total out of that. And then in the back of the class, we have our igneous rock kits. You're going to identify them by the 3 different textures: basaltic, granitic, or andesitic. Out of those 8, I'll grade yours as a total. All right, thanks, guys.